So hello everyone, you are welcome to today's lesson. And today's lesson is still on functions. We are still looking at functions and functions. We've had 4 lessons. So this is going to be lesson 5 of relative math functions. Relative math functions, really relative math functions. Okay, so in lesson 5, we are going to continue from where we left off in lesson 4. In lesson 4, in lesson 4. Lesson 4, you were given this assignment. So quickly, let's go through. After that, we'll do more questions of this nature. In lesson 4, the main objective was to know how to find a simple function given one function, or one simple function and a composite function. Okay, and we had 2 different ways of dealing with it. In fact, 2 situations, and each one has a peculiar way of dealing with it. So quickly, let's look at this. Was the question. Okay, so A. So as usual, solution. You will not write assignment. Questions are numbered because we want you to number your solution. And here, the question number here is A. Given, you extract. Okay, the first function came in the relation form. You thank God. The second function came in the mapping form. However, when you are extracting the corresponding relation form. And here we need to find h of s, given g of s and the composite function here. If you remember, we said, okay, and I said that anytime, okay, you have a situation of this sort, okay, the easiest of all the 2 situations will be the one that you can directly substitute, meaning the function that, okay, you are given is the function that you are going to substitute. Yeah. Okay, more or less your outer function. Okay, so in this case, I asked myself, my composite function, the meaning of this one is G, I feed it with h of x. I asked myself, is G given that I can feed with h of x? And the answer is yes. So, okay, I know G, so I can feed. So in this case, I will come and use the direct meaning of what? G of h of x. And G of h of x means G, I feed it with h of x. Okay, so at the normal circumstance, you proceed to substitute, okay, h of x wherever you see x in g of x. But after that, you know that that result must also be equal to what you are told or you've been given, that g of h of x is equal to. So I said, once we mature, you know g of h of x, you are told is 7 minus 3x, so you write it. Then g of h of x, which came by way of your own interpretation, okay, which is the right interpretation anyway, will mean wherever I see x in g of s, I put h of s there. So my g of x is here. So it means I'm going to get 7 minus 3. This x now becomes h of x. So that's what I have here. And as you mature, instead of writing the whole of the h of x, you can write h there. You know that the function h of x is the same as the function h. Okay, the function g of x is the same as the function g. Okay, so as you mature, going forward, especially where you have more than a variable in the function that you are going to substitute, it's better you use, okay, just the letter representing the function. It makes your work better and easier to relate with. Okay, so at this point, having done the substitution, you can see that, okay, you have an equation, okay, containing h of s, which is your function of interest, what you are looking for. So you just make h of x the subject. So that means this h of x is negative here. I'll move it to this side, which becomes positive. So once I move it to this side, then it means all the terms here must also be moved to this side. I will usually do the movement here mentally and land at my answer. I wrote it here for the purposes of explanation. So 2 will be here, 7 will come, it will be negative 7. Minus 3x will come, it will be positive 3x. And at this point, you know, if you combine this one, you are going to get negative 5, then plus 3x. And I told you that anytime you have a positive term and a negative term, which one do you start with? Which one do you start with?
The positive.
The positive. But surprisingly, some of you started with the negative. Meanwhile, there is a positive term there. So please don't let, okay, this repeat itself. Okay, you've learned something new, learn to apply it. Okay, so in that case, we wrote the positive 3x first, followed by the minus 5. So it shouldn't be minus 5 and plus 3x. Please take note. Write the positive first. Okay, so That will be it for the first one. So you can see that if you can do direct substitution, usually it's very easy. So check that one first. It's when that is not satisfied or it's not possible, then you come to the other approach. So let's look at the second question, which will bring in the other approach. So what are we giving? You extract. And please, I've told you when you are writing the given in your solution, don't write what? That. Don't write that. And again, because immediately you come and write this, given this, and you come and write find h of x. How can you have a question in your solution? I've said this times with that number. You shouldn't have that. So the next time you do that, I will again cancel it. I will give you M0, A0 until you start doing the right thing. I will teach you how to protect our marks. And I will compel you to because I need it. If you don't need it, I need it. Okay, because your A1 is paramount to me. I need A1, not B2. Okay, all right. So now what do we have? Okay, as you extract, you cannot come and write find inside. You know, whatever you are asked to find, that's what you write next in certain situations or in most situations. But here, I am asked to find g of x. So let me see. Okay, g of x. Okay, now g of h of x means g, I feed it h of x. Do I have g given that I can feed? No, I don't have g given. So in this case, I cannot use the direct interpretation and therefore direct substitution. So this means I have to do extra work. Okay, and by that we use that concept that your outer function will always be equal to what the composite function fed with the inverse of what the inner function. So it will be g of h, which is your composite function. If you feed it with the inverse of the inner function, which is h in your composite function, you will automatically get what the function that is here, the outer function. Please take note. So we know that we write by g of s will be equal to g fed with that. So at that point, we know that, I know g of h, that I can feed with any function. But unfortunately, I don't know h inverse that I can use to feed g of h. So what do? I set out to look for my h inverse of x. So for h inverse of x, you know the steps that you are supposed to go through. Let y be equal to your h of x, which is 3x minus 5, interchanging x and y. And again, I told you that when it comes to making y the subject, don't write making y the subject. And those of you who did that, you realize that I canceled it. It's not necessary. What you write will be the let and the interchanging. The rest don't write. Your steps will let us know what you are doing. So in this case, I'm making y the subject. So I maintain the y here. In my mind, I'll maintain it here. Then I'll move this one to the side. So it will be x plus what? 5. Okay, I would write it again in divided by 3 because I'll consider the whole of this as a term because I will divide the whole of that by 3. And in that case, I will get my y to be equal to this. And immediately you divide and you get your y. You know that y will represent your h inverse. So you have to land at the h inverse for us to know that you have found what you are looking for, which is the h inverse. Don't end with the y. And again, if you are finding the h inverse or you are ending with the h inverse is a means to an end. So don't write therefore there. You can write implication or ignore altogether. And now that you know h inverse of x, you can go and write therefore whatever that you were asked to find, which is the g of x here, you can substitute your h inverse of x. So it means g of h, of h inverse of x, you know h inverse of x, which is x plus 5/3, you substitute. Okay, now, what does this mean? Wherever you see x in g of h, we substitute x plus 5/3. Okay, you have therefore already here. So where is g of h? G of h is 7 minus 3x. So this x becomes x plus 5/3. So that's what we have here. Then you know before you multiply, check if you can reduce. Okay, this is a factor, so this can cancel. So if you cancel this, there will be 1 left here. Those who are matured can move from here to this straight away. So in this case, I decided to leave it this way. This step is just for explanation purposes. So at this point, what do? 1 is here, remove the brackets. Okay, minus x minus 5. So one of the terms will be positive if you combine after expansion, like terms to combine. One will be positive, one will be negative. Thankfully, if you combine, 2 will be positive. So you write that one first, then minus your x. And please, you cannot come and write therefore g of x is equal to this again, because already you've written therefore. Okay, the reason why you started with therefore here, for it to be embedded in your step, is to ignore your conclusion with a therefore here, your final statement with a therefore. So if I'm reading this, it comes up here to be therefore g of x is equal to this. So you don't have to write it again. So those who did that, you realize that I canceled that. Okay, and I put a question mark there, or I ignore the question mark. Please, is everyone okay? We'll do more today. However, we'll handle a little more complex functions. These functions are the composite function pretty no fraction. The simple function also give you no function pretty, no fraction. Okay, so we'll look at a situation where there will be a fraction. All correct. Is my point well made?
Yes, sir.
Okay, all right.
Yes,
So
sir.
now those of you who had everything right, please pardon me. Okay, it's not a waste of time. You know, as your sisters are learning something, definitely you should be happy. Okay, they are solving their problems. You should be happy. So now let's go and see, okay, the next set of questions. Okay, we have about 6 questions. Okay, 2 each for A, B, and what, and C. Okay, again, composite function, a simple function, you are finding the other function. Okay, so quickly, let's go and look at the solution. Okay, so as usual, so you read a question, you underline the salient part, if any. Okay, there is no salient part for you to underline. Okay, so you come and write solution. Questions are numbered because we equally want you to number your solution. So 2. Okay, then there is a sub question number A. Apart from that, you have I as well. Okay, so sorry, I, not I. So I'm going to pick the information there. So giving, okay, the information attached to this exact question, I have my composite function f of j of x, okay, and that is equal to what? 3 minus x. And your other function came in the mapping form, you know how to extract it. So j of x, and anytime you are writing, you write close to the margin. You can see that so far, that's what I've been doing. That's the advice, and that's what I also do. Okay, so this is what we have. Okay, so now let's see, we need to find f of x. Okay, so given g of x and the composite function. So let's see whether the direct meaning of the composite function here will, okay, tell us that, or will allow direct substitution, because usually that's the easiest. So f of g of x means f, I have to feed it with g of x. Do I have f that I can feed with g of x? Do I?
No, please.
No. Okay, so it means you cannot use the direct substitution one. So we have to go and use the inverse what approach. Okay, so the inverse approach we know always. So you come and write but. Immediately you know that, forgive me, the inverse approach is what you are supposed to use. Okay, you know your outer function, which is f of x, okay, will be equal to, okay, we said the composite function that you have here, which is f of j. You feed it with what? The inner function, its inverse. So it will be j inverse of what? Of x. All correct?
You come again.
Okay, all right. Were you with us in our previous meeting? Please, were
Yes,
you with us? You were. Okay, I
yes,
guess, okay, Easter has taken everything away. All right. Okay, you chilled too much during the Easter, that's why. Okay, no problem. So this is it. I don't want us to go back, but you know that what you have here, the same as f, you feed with j of g inverse of x. Okay, but you know that the composite of a function in its inverse will always give you x. So indirectly, this is what you have, which is the f of s that you are looking for. In that meeting, I explained all that, why this is the situation. So don't let us go back. When you have time, you can go, the videos available, you can go and watch. Okay, so because we've gone
yes, sir.
beyond this, we've gone beyond this. As for how to state it, it will always be your composite function, okay, fed with the inverse of the inner function. That is the function that is closer to, okay, your brackets. That's what you are going to feed. Outer function, inner function. if it's the outer function that you are looking for, it will be the composite function fed with what? Your inner function always. So your outer function will be that. Okay, so on that note, we know we have f of g that we can feed with anything. Okay, we can feed with anything at all. But unfortunately, what we are going to feed, which is g inverse of s, we don't know. Okay, so we have to go and find it before we come and substitute. So at this point, you write for, okay, g inverse of x. What do? We will first of all let's, okay, your y be equal to g of x, which is the function that you are finding its inverse. That is 2s plus 1. Okay, then what do? You interchange. Okay, and anytime you you can say that the for, I started with a capital letter, the but, I started with a capital letter. Okay, in English, anytime you are starting a sentence, that's what. So so what do you interchange it? Okay, x and y. Okay, we are going to get here x, and anytime I'm writing, I write close to the margin. It's equal to 2y, okay, plus what? 1. So I'm making y the subject from here. Y term here is positive, so I'm maintaining it here, but I'll write it here first. So 2y, that doesn't mean I have moved. Okay, and I will move this one, which will give me x minus 1. I write it again before I divide. So over 2, over 2. My professors, are you following?
Yes, please.
So I will get
Yes,
y.
yes.
So I know that the y will be the same as the inverse function. So instead of writing y is equal to this, I'll write this implies that an inverse function is a means to an end. Is the inverse of which function? The inverse. Okay, and that will be x minus 1 all over 2. Because the denominator contains no variable, it means I don't have to attach any constraint. There is no constraint. Okay, in our next meeting, we'll start dealing with the domain, finding the domain of a function, which invariably will mean the constraints. So I know G inverse, so I'm in a comfortable lead. If I come and substitute G inverse in f of J, my results will automatically give me my f of x. No. Okay, 1 minus x is not the same as x minus 1. Okay, is it supposed to be x minus 1? Sorry, 1 minus x. I maintain this one here and move, so it's supposed to be x minus 1. It cannot be 1 minus x. The two are not the same. One is the negative of the other. Is that clear, Prof. Mawuyo? Okay, so now what do we do? Okay, great. Okay, so we can, oops. Okay, so we are going to get, okay, you substitute. So therefore, your G inverse f of x that you are looking for. Why is my here? So f of x will be equal to, we said it will be f of G inverse. And what is your inverse? You know that it is x minus 1 all over 2. Okay, so this will be equal to, this means wherever I see, okay, my function of interest is f of J, which I know it is this. So wherever I see x in f of J, I substitute what? X minus 1 all over 2 there. So that gives me, okay, I have this f of J, so I'll get 3 minus, my new x is what? I'll put it in brackets. Remember that advice. It's x minus 1 over 2. Is my point well made?
Yes, please.
Okay, so
Yes.
now I can remove the brackets. Okay, so this gives me 3 minus, okay, x minus 1 all over 2. So you come and take the LCM. Okay, so over 1. Your next step, you take the LCM. Remember, I've told you for every algebraic fraction, unless otherwise stated, leave it as a single fraction. It's only under that situation that you can see if you can further reduce. Okay, so my denominator here will be 2. 1 will go into 2 how many times? 2 times 3, so I will get 6. Then minus 2 will go here how many times? It will be 1 times the whole of my numerator. But because I have minus there, I'll put that in brackets. So x minus 1. So that in effect will give me 6 minus what? X. Okay, then plus what? 1 all over what? Over 2. So in effect, I'm going to get what? This plus this will give me 7 minus what? X all over 2. All correct. Is my point well made?
Yes, please.
Yes, please.
So this is how far you can go with the I. Let me see whether I created, there is an enough room. Okay, this one is B rather. Okay, so I need to go and create, okay, another space for the I. We've done the I, or we are still on the I. Okay, we are still on the I. Okay, so let's see if I can squeeze the I somewhere here so that I don't create any, okay, space. Okay, so for that. So in this case, what do I have? I. That will always be very easy. What are we giving? We've been giving, okay, f of g of x, okay, to be equal to what? 3 minus x. Okay, I will come down because I want to use this space. And, okay, what am I giving as well? F of x is equal to what? X plus 1. So let's see what we are going to get. Okay, so in this case, okay, f of g. Okay, do I have f that I can feed with g? Do I?
Yes, please.
Okay, so it means this one will allow the direct substitutions. I will write, but, okay, my f of g of x, I know is equal to what? F, I feed it with what? G of x. Okay, after this example, I won't use the g of x. I will use g, f, and what have you. I won't use the of x. Later, when I'm concluding, then I'll bring the x. So in this case, f of g of x, I know is 3 minus x. So this implies that it's an equation. So 3 minus x is equal to, okay, f of g of x means wherever I see x in f of g, I put, okay, in f of x, I should say, I put g of x there. So it will be 3 minus g of x. Okay, which in effect will give me, I will move this one to the side. So g of x, okay, I will do that mentally. So therefore g of x, okay, will be equal to, okay, this, the 2 will also come here, these two terms. So I will get 3 minus 3, that will go. Then I will get, okay, this will give me x. All correct. Is my point well made?
Yes, please. Yes,
Okay,
please.
very good. All right. Any issues?
Please, how did you get 3 minus g of x?
How did I get what? 3 minus g of x.
Yes, please.
Okay, so I use this side. F of g of x means wherever I see x in f of x, it's g of x. So I see x here. Hey, no. So it means that all of you were not following. Okay,
Please,
this one,
I
it
was about
wasn't,
to tell
you are
you.
about, so I rather use f of g instead of f of x. Okay, so please, let's go and do the needful. This can also happen to you. Okay, so usually, especially if my mistakes are not that, okay, intentional. Okay, it's more or less, I tell my student that it's a way of God talking to you, that you can also make that mistake. When you get there, you have to be very, very careful. Okay, so now let me go and do the needful. Okay, so those of you who were saying yes, 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 actually you were not following. Okay, all right. Okay, I think now we are good to go. So that will give us, it is f, you feed the g of s, and this is f, your function of interest is here. So it will rather be g of x plus 1. Is that clear now? So I guess that's why you didn't get it. Okay, so now your g of x is positive here. So therefore, g of x, okay, in my mind, I've maintained it here, and I'll move this one to the side. That will give me 3 minus 1. That will give me 2. Okay, then minus x. I'm done. Just to see how they are far, we don't have any issues. So even this line, okay, it's not relevant. Let me clear it. I thought maybe the solution will go beyond that. Okay, the space there. So let me clear it. Hello, my professors. Is everyone fine?
Yes, please.
Great. Okay, so we are going to move on to the B. Okay. Today I'll compel everyone to write. Okay, so meaning there will be a class exercise. Then we'll come back and mark together. Okay. So let's do the second one. Okay, equally to better our understanding. Okay, so far. Okay, so now B. Okay, again, BI. We are looking at 2BI. Okay, what are we giving? Don't attach the dots. Golf, G of f of x is equal to what? 1 minus x. Okay, and your f of x is equal to x plus 1. Okay, what are we supposed to do with that? We are supposed to use that to find g of x. So let's see. You are looking for your alpha function. So if immediately you become matured and you realize that it's the alpha function that you are looking for, you should know that it will always be the inverse approach. If it is the inner function that you are looking for, it will always be the direct substitution approach. Okay, so in that case, you can choose even not to ask yourself that question. Okay, the function given here is the inner function, but I don't know the outer function, which obviously will be the one that I'm supposed to find. So I will use the inverse approach. Or better still, you ask yourself, G of f of x means G, I feed it f of x. Do I have G that I can feed? The answer is a big no. Okay, so it means I have to use, again, the inverse approach. So I'll write, but my outer function, which is the function that I'm looking for, the G of x, will be equal to, okay, we said it will be the composite function fed with the inverse of what's the inner function. So it will be your composite function, which is G of f, fed with the inverse of the inner function, which is f inverse of x. All correct. Okay, so there's a concept that you need to know. I've told you, native math is all about concept. After getting the concept, the rest will be algebra. So if your algebra is not strong, and even if you have all the concepts, you will struggle. Okay, so in this case, this is what we do. Okay, we will need f inverse of x. So for f inverse of x, which I can even write for f inverse without the x, is simply understood to be there. Okay, I will let, okay, y to be equal to f of x, which is x plus 1. Okay, then what do I do? Okay, I interchange the variables. I know the variables, so I will be more specific. So interchanging the variables, which are x and y. Okay, then what do we get? We are going to get, okay, x to be equal to y plus 1. You make y the subject, so you maintain your y. So your y will be equal to x minus 1. So this y becomes the inverse. So this implies that the inverse, or you can just choose not to write the implies and write f inverse of x is equal to x minus 1. All correct. Are we all fine?
Yes, please.
Okay, great. So now at this point, what do? We are going to substitute this into the composite function. So at that point that you are going to substitute from where you stated your relation, you can conclude there, or someone can use implication and later conclude. So this will be equal to your g of f fed with the inverse function, which you know, a pretty function x minus 1. So now what do we, and remember I told you, anytime you are finding the inverse of a function and the coefficient is 1, okay, of the x is 1, always you negate the middle, or yes, you change the sign in between the terms. And so that's exactly what we have here. Okay, all right. If it's the other way around, you change the sign between the terms, then you divide by the coefficients. Okay, of the
Please,
x.
can you take it again?
Okay, all right. In any case, I was just teaching you how you can look at the function and state its inverse. But that's not part of what I'm saying. We've done that. I said anytime you are looking for a function, a linear function for that matter, and you realize that the coefficient of the x is 1, its inverse will always be, okay, change the sign between the terms, so x minus 1. If the coefficient is, okay, it's not 1, then its inverse will be change the sign, they divide by the coefficient, as simple as that. So it means if I have f of x or a function f, okay, and it's equal to maybe 2x minus 1, I know that inverse will give me s plus 1 over 2. You get it?
Yes, thank you.
You're welcome. Okay, but please, if it's a subjective question, don't do this for me, I beg. Okay, subjectively, you have to go through all that I'm doing. Okay, I'm doing that not because, okay, I love to write, because you have to, okay, write as well. Okay, it's very necessary. So at this point, this will be equal to g of f, we know. So we can feed with x minus 1. So this means wherever we see x in g of x, okay, we substitute x minus 1. So this is your g of x. There is x here. G of f, there is x there. So let's go and carry out the substitution. That will give us 1 minus x. You have two terms, so it will be x minus 1. So that gives us what? 1 minus x plus 1. Okay, if you combine like term, your first term will be positive minus what? X. Afa, you've already drawn your conclusion, so don't come and draw, okay, your conclusion. Okay. Point well made.
Yes, please.
Okay, very good. So now the II. Okay, and this one will be for all of us. So what do we have? We are going to have this. Okay, what are we giving? We've been given, okay, g of f of x. Again, g of f of x is equal to 1 minus x. And you know you've been given your g of x. Okay, it's equal to 2x plus 1. Okay, so let me go and mute the one who is. Okay, so now you you can see that I use comma. You can also use comma or end. I've told you that in maths, comma can also mean end. Okay, so because of space, that's the more reason I wanted it to go there. So at this point, I'm looking for my inner function instead. Immediately you are looking for your inner function, you should know that direct substitution is the way to go, the direct meaning of the composite function. So here I write but, okay, and B with a capital letter, my g of f of x, okay, will be equal to, okay, you know it will be j, I feed with what? F of x. Okay, so I'm feeding j with f. So wherever I see x in j of x, okay, I will feed it with what? F of x. But I've told you, instead of writing the whole of the f of x, this time I will write the f. The meaning is the same. So this is what I'm going to do. Okay, so I'll write g of f of x, I'm told is 1. So this implies that 1 minus x is equal to, by the meaning of this will mean wherever I see x in j of f, I put what? F there. So that would be 1 minus f. Is that clear? Hello, my professors, are you with me?
Sir, please come again.
Okay, so you can see, instead of writing f of x, wherever I see x here, okay, you can see there's g of f of x. So it's g, I feed it with f of x. Okay, so that will give me 1 minus f. Am I right?
Yes, sir.
Yes,
Hey,
please.
hey,
No. No, sir.
you see,
No.
it means you are not learning. Okay, is the mistake that I did initially that I've repeated just to see whether you are, okay, conscious of that mistake. Your function of interest here is what? What's your function of interest?
2x plus 1.
No, your function of interest, the name of the function of interest
G of x.
is J. Your function of interest here is J. J, your function of interest is always the function that you are going to feed. Is that clear?
Yes, please.
Okay, so your function of interest here is J. So it means you should come here, not J of F. What I took J of F as my function of interest. No, it was this one rather that J of F was our function of interest because it was J of F that we're going to feed. You get the point? So please take note. Okay, your assignment will come very soon and you don't repeat that. Okay, all right. because immediately you do that, you know you are doomed from that, okay, point. Okay, so now it means wherever I see x here, rather, I will put f there. So it will be 2f, f is a function, plus what, 1. And I'm looking for f. Okay, so what do? I can write the 2f here is equal to, in my mind, I've maintained the 2f here, so I'm moving this one to the side. So that will give me 1, okay, minus 1, that will go. That will give me 0. So I'll get minus x there. Is that clear? Professors, are you following?
Yes.
Okay, so you are looking for f. You write it again before you divide. So minus x over 2 over 2. So therefore, my f, which is the same as f of x, will be equal to minus x over 2. All correct?
Yes, please.
Okay, so very good. So that will be it, okay, for, okay, what we are supposed to do together. Now, you are going to do these two as a classwork. Now, you submit it. I'm giving you 10 minutes. Okay, 10 minutes is enough, okay, to submit this. Okay, take notes. I'll put it on the platform for you as well. Okay, you submit, will come and mark together. And so for you to recognize what went wrong and how, and why as well. Okay, so you are welcome back. Okay, from the water break. Now let's quickly look at the solution. Okay, then you mark, okay, yourselves. Okay, so question 2C, as usual, you extract, given the two functions, one is a composite and one simple function. Okay, then after that, here you ask yourself, okay, I'm looking for the outer function. So anytime I'm looking for the outer function, I have to use the inverse approach. So my outer function will be equal to my composite function fed with what? The inverse of the inner function. Or better still, do I have f that I can feed with h? No, I don't have. So I have to use the inverse approach. So I set out to look for my inverse. So for h inverse, I will interchange x and y. Make, okay, y the subject. So you end up getting this as y. Immediately you get your y, you know your h inverse. Okay. And at this point, take note, you can now go and substitute. So it means, therefore, my f of x will be equal to f of h fed with h inverse, and that is what you just found. Okay, this means your function of interest now is f of h. Wherever you see f of h, x in f of h, you put s plus 5 all over 3 there. So your f of h is this. So wherever I see this x, it becomes s plus 5 over 3. So it will be 3 times s plus 5 over 3. I'm substituting, I put it in brackets, minus 4. But before I multiply, let me check if I can reduce, and I can reduce. If I reduce, I'm going to get in bracket s plus 5. But because 1 is, okay, outside the bracket, it's not necessary for me to introduce the bracket. Then minus what? 4. And if you combine this, you end up getting x, okay, plus what? Plus 1. Okay, so that is supposed to be your answer. And the second one, f of h, f of x. Okay, you are supposed to, you are finding your inner function. So it means here the direct substitution is the way to go. So f of h means f, I feed it with h. Do I have f that I can feed with h? Yes. So that is f, I feed it with what? H. So now, okay, I'm told in the question that f of h is equal to this. So I can write it on this side. And by the interpretation of this, the same f of h will be equal to wherever I see x in f of x, I put h there. So h plus 1. Instead of writing h of x, remember I said we are mature. So h is the same as h of x. Then at this point, I make h the subject. So I will move this one to the side, maintain the x. So the h, I should say. So in my mind, I've kept this, so therefore, then I will move. So I'll get 3x, okay, minus 4 minus 1. So that will give me 3x minus 5. Okay, so this lands me at my answer. So look at the mark allocation. If you extract B1, take note. Okay, I wanted to make it B half so that's okay. So it's B1. This will also be B1, where you use this particular fact. Okay, it's B1. Okay, where you let half be half interchanging, okay, b half, or what do you call it? Making your process of making the first one, m1, okay, you divide m1, okay, and this one, your a1 for your inverse function. Then, okay, this gives us what? Where you go and substitute m1, okay, where you now do the actual substitution into the composite function, also m1. Okay, after that, this is also m1, a1. Okay, so Cadmiel, okay, so you said you have submitted yours. Okay, you mark and I will get that as well. Okay, Alexandra, well done. You've done the right thing. Okay, so only that is relative maths. Instead of relative maths, you are supposed to use e-maths. Okay, so that's just by the way for what you have. If you come to II, okay, please take notes. Okay, B1 for your extraction, B1 for this fact. Okay, then, okay, your substitution M1, your final answer A2. So 10 marks for I, 5 marks for no bonus today. Okay, no bonus. 10 marks for what you have here, the I, 5 marks for. So mark and grade yourself. So whatever over 10, whatever you had over 10. If it's 10 over 10, you write 10 over 10, 6 over 10. Then this one to whatever you had over 5, 5 over 5, 4 over 5, what have you. Take note of that and submit when you are done. Okay, submit. However, this will be the penalties. Immediately, okay, you don't write solution first minus half. If you don't number your question at all, M0, A0, numbering your question critical. At this point, I don't have to tell you again because I've been saying it over and over. Then again, if you come and write therefore here, okay, it will be minus half. This is not your conclusion. Take notes. Okay, then after that, what do we do? Okay, we should be good to go. Okay, at this point, therefore should come, or you can use implication, but your conclusion must come. Okay, as well. Okay, so you know what to do. Now, gradually, you are becoming expert in marking. Okay, so mark, then give me your feedback. I realized that most of you did exactly what was expected of you, the ones that I checked. So you are doing very well. Keep it up, especially with the pretty functions. Okay. So at this point, I guess we can move on. Can we move on? Are we all done marking? Okay, so please, okay, let's move on. Okay, so Prof. Peter, it's supposed to be Prof. Peter in brackets, Form 1 E-Maths, not Form 1 Prof. Peter. So please go and edit your page name. All right. Okay, so now let's go to the next question. Okay, I want your attention to be here. So when you are done, okay, please let me know. All right, okay, so now let's go and look at our next set of questions. So question number 3. Okay, again, we are dealing with composite sample, find the other sample. Okay, so now, okay, let's go and look at the solution 2. Okay, I will start with the A. So as usual, and here, okay, apart from f of x, okay, in this question, that is pretty. You can see that the composite function is not pretty at all. Okay, a rational function. But don't worry, we know how to deal with it. Okay, so question number 3. Okay, A. Okay, what am I giving? So giving, I don't attach the dots. Okay, and what do I have? F of x. Okay, to be equal to 2, okay, x minus 4. Okay, and, okay, I think I will come down. My f of g is also in the relation form, so I thank God. F of g of x is equal to, okay, 6x plus 12. Sorry, it's minus 12 in the stead. Okay, so minus 12. Okay, minus 12 all over, okay, 3 minus x. But the constraint attached, so x, you equally have to attach that's not equal to 3. We need to find g of x. So let's see. Okay, f of g of x means f, I feed it with g of x. Do I have f that I can feed with g of x? And the answer is big yes. Do you agree?
Yes, sir.
In any case, we are looking for your inner function. So direct substitution. Anytime direct substitution is allowed, you do your sign of the cross. So now, what do? We will come and write, but we use the direct definition or meaning, interpretation. F of g of x will be equal to wherever we see x. Okay, in f of x, we put g of x there. So it will be f. We feed it with what? G of x. That's the meaning. Okay, so now, what are we supposed to do? This implies that, okay, your function here, we know f of g of x is the same as this. So I'll write that one there, f of 6, x minus 12, all over 3 minus x. And that should be equal to, wherever I see x in f of x, I put g of x there. But remember, I said no longer g of x substitution, we substitute g instead of g of x. Okay, so it will make our work a little, okay, pretty. Okay, so in this case, my function of interest here is now f. So wherever I see x in f of s, I put j there. So it will be 2j minus 4. All correct? Is my point well made?
Sir, please come
Yes.
again.
Okay, all right. As for this side, you get it. Is that not it?
Yes, please.
Okay, so it's the same as what you are giving. And this means f, you feed it with what? G of x. So the function of interest here is the function that you are going to feed f. Okay, and it is here. So your new x is now g of x, which I said instead of writing, you know that g of x is the same as g. F of x is the same as the function f. Okay, even in the comma test, I think you had my attention drawn to where, okay, I said the functions f and g are instead of g and h also. Okay, so you knew that we could label functions as such. Okay, so in this case, what do we do? Okay, we said wherever we see x in f of s, your function of interest, it becomes, okay, j. So f of x is this, there is x here. So it should be 2, your x is now j minus 4. Afa. All correct now? Those who said I should come again. Hello? You are not minding me.
Yes, please.
So I'll take your silence to mean you are fine. Okay, so at this point, what are we looking for? You are looking for Jane. So you make Jane a subject. Only that this time around, you obviously can see a little more work. Unlike the other one that you have to immediately you combine, you get your answer. So this one, you move this one to the side. So I'm going to maintain my 2G here. I'll write that one first anyway, to be equal to, and this will be I'll maintain this, which is 6x minus 12 all over 3 minus x. Then I will move this one to the side. That will give me plus 4. All correct?
Yes, please.
Okay, but remember, okay, we know before we even go and divide, take note, we have to express the side as a single fraction. It will always be better and convenient for us to do so. So expressing this as a single fraction, okay, this is what we are going to do. Or someone equally can write this divided by that, but our advice, express this as single fraction before you go and divide.
Please,
Okay, so
won't the signs change?
yes, the signs changed. I maintain this in my mind. Okay, if you cannot do that in my mind, I've maintained this one here, though I wrote it first. Then it is this one that I will move. So this is maintained, I maintain it, and I move this one, it became plus.
Awesome.
You get it? However, if you don't do it, then you are supposed to maintain the 2G here and move. So it will be 6x plus minus 12 over 3 minus x plus 4 equal to 2G instead.
I get it now.
Okay, better. All right, good. All right, so now we can move on, okay, to what we are supposed to. So LCM here, so it means 2G will be equal to LCM over 1. So your denominator will be 3 minus x. Do you agree? 3 minus x will go into 3 minus x how many times? 1 times your numerator. So that will give you 6x, okay, minus 12. Then plus, Okay, 1 will go into 3 minus x how many times? 3 minus x times that times 4. So it will be 4 into 3 minus x. Point well made, or I should come again?
Please come again.
I've never asked this question that I've been let loose before. Okay, all right. Okay, so yeah, we know how to write, okay, algebraic expressions as a single fraction. Take your LCM, just like how to write, okay, numbers or fractions, okay, as what? A single fraction. So your LCM will be 3 minus x. You take your LCM. So it will be this times that, you know. Okay, 3 minus x. 3 minus x will go into itself how many times? It will be 1 times, then times this. 1 times any number is a number itself. Then plus, okay, 1 will go into 3x minus 3 minus x how many times? It will be 3 minus x divided by 1. So any number, okay, 1 will go into any number, the number itself. So it will be 3 minus x. But it will be times 4. So because this is a binomial, it will be 4, then you put this in bracket. Without the bracket, the 4 will multiply only this. Meanwhile, the 4 must multiply, okay, the number of times 1 will go to what you have there. Is it clear now?
Yes, please.
Okay, so with this one, you can see that we have the concept now is between us and our algebra. Okay, so the denominator will be, okay, 3 minus x. That is intact. We go to the numerator, we need to expand. Okay, so 6x minus 12. This, if you expand, you get plus 12. Okay, then minus 4x. Do you agree?
Yes.
Okay, so we end
please.
up getting 2g is equal to denominator, little or no work. You write that one first. That's what I do. Then I go and use my energy on the. So the minus 12 plus 12 will go. So I'll end up getting 6x minus 4x, and that will give me 2x. All correct.
Yes.
Okay, so right now we are in a very comfortable lead. You can see that now your fraction here is prettier compared to where we started. Okay, so at this point, we are looking for G. So we divide both sides by this is a single fraction. So I can write divided by 2. I can change. Okay, so that will give me 2G over 2 is equal to 2x over 3 minus x divided by 2. Is that clear? I don't want to use the bar again. Okay, other than that, you can do that. It's the same thing. Can we move on, my professors? Are you following?
Yes, please.
Okay, Prof. Paulette Paris.
Please, can you time straight away, or you have to divide?
Oh, you
show the
can, you
division
can, you can. You can show that this is the same as times 1 over 2. You can. It's the same
before
thing. Only that this is
it
just for explanation purposes.
times.
You can. There's nothing wrong with that. Okay, you can. Okay, all right. So that will be my next step. So meaning you can move to this particular step. So 2x over 3 minus x, then times 1 over 2. Is that clear? So now I know these two can cancel this. Do you agree? Hello, are you with me, my
Yes,
professors? Okay, so you
Yes,
land
please.
at your answer. So
Yes.
I'll draw my conclusion at this point. Therefore, g of x, what I was asked to look for, not g, okay, though is the same, will be equal to x over what? 3 minus x, am I right? Okay.
yes, please.
Do I end
Yes.
here?
No, please.
Okay, what is missing?
The con-
Constraint.
The constraint, very good. Okay, all right, okay. So I owe you one Aloha. Do you know Aloha?
No.
You don't know Aloha, so small boys are young, small girls are young. Okay, it's a kind of toffee. Okay, anyway. Okay, when you eat, okay, the color of your tongue changes. Okay, so in this case, okay, comma, it will be x not equal to what? Not equal to 3. Okay, so that's how far we can go with the A. All correct.
Yes, please.
Okay, very good. You are doing well. Keep it up, especially those who are really following. And indeed, okay, those who are not following and they are drawing my attention and now they are following. If you are not following and you are quiet, okay, please, you know I don't like that. You shouldn't like it as well. Okay, so this will be it for the solution to question 3A. If you are fine, we'll move on to that of the B. Okay, then maybe we'll do C and D will be yours. Okay, all right. So no questions. Once we have our concept, we have to be very careful with our algebra. Okay, be very careful. So now let's go and look at that of the B. Okay, all right, so B. Again, what are we giving? You extract. We've been giving, okay, the composite, unfortunately, the composite is in the two functions are all in the mapping form, but unfortunately, we know how to extract. We are not bothered. Okay, we know the kind, okay, and how to deal with it. So now we are going to get 1 over 2x minus 2. And our second function, okay, it's quite pretty. Okay, but should I skip B and do the D? Because D, the two functions are not pretty. If you're able to do the C, then you should be able to do the B, sort of. But no issues. Let's try. Okay, so we are going to have f of x. Okay, is equal to 2x minus 4. Okay, one of the functions again, pretty. So what do we do? Okay, we are good to
Sir,
go. Yes, please.
you forgot the constraint
For the first one,
G.
okay, very good.
Yeah.
Okay, you equally extract, so x not equal to what? Okay, let me do the needful. I don't space. Okay, it wasn't intentional. Okay, so thanks for drawing my attention to that. So it means you know the writing, so you equally do it. So x not equal to, okay, 1. And okay, so now, okay, g of f, yeah, I'm looking for the outer function. Okay, so that will mean more work. G of f, do I have G that I can feed with f? No. So again, I'm looking for the outer function and I have to go through the inverse. So I'll write but my inverse, which is, okay, G of x will be equal to, okay, G of f, I feed it with what the inner function's inverse. So that will give me f inverse of x. All correct?
Yes.
Okay, so this will mean a little more work. Okay, sort of. The direct substitution usually is easy. Even with the one that we had, okay, you can see that it involved, okay, a little more work. So now we go for the inverse of f. So you have to come and write, okay, so for f inverse of x, who can look at the function f of x and tell me the inverse straight away based on the information that you've been given?
1.
The inverse will be 1.
X plus 4 over 2.
S plus 4 over 2. That will be it. Take notes. Change the sign between them. Divide by the coefficients. As simple as that. Okay, so now let y be equal to your f of x, which is 2x minus what? Minus 4. Okay, so in that case, the next step will be interchanging. Okay, x and y. And as we start marking together, you know very soon your test will come. Okay, all right. So now what do we have? We are going to get what? X to be equal to 2y minus 4. Okay, so you make y the subject. In my mind, I'm maintaining the 2y here is positive. The fact that I've written it for doesn't mean I've moved. So I'm going to get x plus what? 4. Okay, then I'll write it again, divide. So x plus 4 all over 2, as somebody said. So this means my function f inverse of x, okay, which is the same as the y, will be equal to x plus 4 all over 2. Denominator does not contain a variable, so no constraint. Okay, so now I go and feed g of f with that. Not that pretty, but a little more work will come in. So I can come and write, therefore, okay, my g of x will be equal to, remember, it will be golf, which is g of f, oops. Okay, g of f, okay, fed with f inverse, and now we know f inverse, that is x plus 4 all over what? Over 2. Okay, so this will be equal to, you can see that anytime I move to the next line, I write close to the margin. Okay, so now g of f, your function of interest, wherever you see x, it becomes x plus 4 over 2. And we know we've done something of this sort before, like this kind of algebra in functions. Okay, 1 over 2 into, okay, x plus 4 over 2, but that's not all, then minus 2. So let me extend this minus 2. All correct, or if you want me to come again, you tell me.
Please come again.
I thought you did this one. Okay, you let me go. Okay, so all right, so this is what I have. Okay, remember, your function of interest here is what? What's your function of interest? G of f, the function that you are feeding. Okay, so your function of interest is this. So if you are looking for g of f, you know, once you know g of f, you know g of anything. You should know g of 1, g of f of 1, meaning you substitute 1 here. But g of f of x plus 4 over 2 means wherever I see x, my new input here is x plus 4 over 2. And in that function g of f, my numerator 1 contains no variable. So I'll write it, okay, over my denominator. So it means it is this x that I substitute. The rest must be left intact. So it will be 2 into my new x, which is x plus 4 over 2, then minus 2. Is that clear now? Hello, my professors, is it better now?
Yes,
Okay.
yes, please.
So on that note,
Thank you.
you are welcome. We are going to get this to be equal to, okay, you need to simplify. Here you can multiply. So this will go into, you can cancel before multiplication. So 1 over, okay, x plus 4, okay, then minus 2, which gives you 1 over x, okay, minus or plus 1, I should say. Okay, but unfortunately, we can't end here. We need to attach the constraint. So x not equal to minus 1. All correct?
Yes, please.
We are fine. Okay, you are doing well. Keep it up. Okay, all right. Okay, Prof.
Please,
Refua.
say,
Yes,
This
please.
is it not x plus 4 minus 2?
Oh,
Yes.
it's plus 4
X plus.
instead. Okay, this one
Uh-huh.
it's not okay. It's not intentional. Okay, so it means at this point I'm doomed. So it will rather be 3. Okay, and this will be minus 3. I've done the needful.
yeah,
Okay.
it's -2, not -1.
So it's
Hey,
minus 2.
then why? What am I? I'm exhibiting symptoms. Okay, symptoms of hunger.
Thank you.
So I better go and eat before I write something else. Okay, going forward. Okay, so let's do the needful. Okay, once you are, and indeed, okay, it's not intentional. I wasn't careful as well. So you have to be careful. Okay, so please take note. So let me do the needful here. I will clear this, clear this. Okay, I avoid deepening, so I will do that as well. Okay. Instead, I would have canceled. You are supposed to cancel it and write it again. So this is plus 4. Then why did I write 1? What was in my mind? Okay, so 2. So this will give you s plus what? 2. Is that clear now? So minus 2. Is it better now?
Yes, please.
Okay, so that's it. So next time, have it easy on me, okay? All right. Okay, so this is okay, so this is what we have. Okay. All right, so we are good to go to the last one. If you're able to do the last one, which is the C, okay, you are in the best of shapes to do that upward of the D. Okay, and I even wanted to highlight the D green. Okay, make it green so that it will appear that it will come in your class test. So let me see this one. G of H of X meaning, okay, J, I feed it to H of X. Okay, so this one you can do it. Then you come and try that one. Okay. So I think, okay, we are good to go. Let's do the C. And okay, the D will be yours as your assignment. So C. Okay. What are we giving? Okay, two functions that are not pretty, both the composite and the simple. Okay, they are G of H. Oops. I told you that I've started exhibiting symptoms. All right. Okay, so don't worry, I'll be careful going forward. So G, it came in the mapping form, but we are extracting the relation form. And that is 3 minus x all over 6 minus x. The constraint not attached. Okay, that's not your problem. Yours is to attach yours when you find it. So and, okay, let me use and instead. Okay, so G of x is equal to, what do we have? 1 over x plus 2. Okay, so at this point, I ask myself, I need to find g of x. G of x is the outer function. Hey, how can I, please, there is an error here. It's supposed to be h of x. You get it? Other than that, you know g of x. So let me quickly go and effect the change before I send it to you as well. Let me quickly do that. So this will be h of x. Oops, it's capital. How? Okay, so take notes. Let me do that from the main. It's possible it's in the main question as well, because that's where, okay, so I think, yes, it is. So this will be h of x, because I usually copy and paste. Okay, so I think we are good to go now. Okay. Hey, am I recording? Okay, I am. Okay. So now this is what we have. Okay, so you've effected a change. I can't give you g of x and ask you to find g of x. So here, okay, you are looking for your inner function. Okay, so substitution would be the way to go. So you write but, you use the direct meaning. Your g of h of x, you know, will be equal to g, you feed it with what? H of x. Okay, so in this case, this implies that you know g of h of x, that is 3 minus x all over 6 minus x. And that should be equal to g of h of x means wherever you see x in g of x, okay, you put h there or h of x there. So your function of interest here is j. So it will give you 1 over, okay, h plus 2. Do you agree? Hello? Do you
Yes,
agree?
please.
Okay,
Hi.
so at least you know at this point that, okay, you need to solve for your h. Anytime you do your substitution, change your subjects all the way. So here, a single fraction, a single fraction. Don't say that you are going to multiply through by the LCM. Just cross multiply. So it means I'm going to get 3 minus x in brackets, okay, a binomial multiplying h plus 2. And that should be equal to this times 1. That will give me 6 minus x. All correct?
Yes, sir.
Okay, so we come and expand. So here you can see that you are going to get 2 terms in h, a little more work. So this time that will give you 3h. Okay, this time that will give you 6. Minus what? Okay, h is a function, so I can use hx or sh. Any of them goes. You know that h is what? Your function. So let me use x what? H. Okay, then minus what? 2x, and that is equal to 6 minus x. All correct. So you have 2 terms in h on one on this side. Okay, so you are looking for h. You collect them on that side and move the other terms to the other side. So that will be equal to, okay, I'm going to move this term and this term, sorry, and this term. So the 6 here will cancel the 6. Can you see that? So if you move, it will go. Are you with me? Then you are going to get minus x plus 2x. If you can't do it mentally, you just move and later add. Okay, so it will give you minus x plus 2x, and that will give you x. All correct. Who wants me to come again? This time around there, I will be lucky.
Me.
Sir, pick me again.
Me.
From where? Okay, do you get the expansion? Hello, do you get the
Yes.
expansion? Okay, then I'm going to write
Yes.
the explanation step for you to get it. I did it mentally. Okay, assuming maybe you have matured, but don't worry. Okay, as you matured, you can also do the same. So you maintain this and this. So that's what you have here. Is that not it? So you have to move this 2 to the other side. So the other side, you already have 6 minus x there. Then you move this one, so it will be minus x. You move this one to plus 2x. Is it clear now?
Yes, please.
Okay, so now,
Yes, please.
okay, 3h minus sh will be equal to, come and combine items here, 6 minus 6, that will go, minus s plus 2s, that will give us the x. So when I did it mentally, I ended up getting the same result. But play it safe. If you cannot do it mentally, do it this way and combine, it's better. So what am I looking for? I'm looking for h. So I factor out h. So I will get 3 minus x here, and that should be equal to x. I write it again before I divide. My professors, are you following?
Yes, please.
Okay, I divide by 3 minus x, 3 minus x. So I will therefore have, okay, my h of x will be equal to x over 3 minus x, but that shouldn't be it. X not equal to what? 3. All correct. Is my point well made?
Yes, please.
Okay,
Yes.
let me write the h where it's looking like I have cancelled the h. Okay, I didn't cancel the h. It's rather the 3 minus s that will cancel on that side. I decided not to show, so this will cancel that. So you'll be left with h is equal to this, and therefore you are looking for h of x. If the question asks you to find h, then you conclude with only h. The question asks you to find h of x, so you conclude with h of x. All correct? Okay, so we thank God for a successful lesson once again, and thank you for your contribution and all that you did. You watch my back, okay, and carefully, and the class once again is a success. God bless us all.